Imagine waking up. The ground beneath you is rust red and frozen. The sky above you is not blue. It's a sickening butterscotch brown. The air is 95% carbon dioxide. If you took your helmet off right now, your blood would literally boil in under 2 minutes. Your eyes would rupture. You'd be dead before you hit the ground. Welcome to Mars. Now here's the crazy part. This nightmare world, this radioactive, frozen, almost airless desert, is the single best candidate for human survival beyond Earth. And right now, as you're watching this, billions of dollars are being spent to send people there. Why? What do we actually know about Mars? And what is humanity's plan for a planet that seems designed to kill us? By the end of this video, you'll understand Mars better than 99% of people on Earth, and you'll never look at the night sky the same way again. Mars is the 4th planet from the Sun. It's about half the size of Earth. It orbits at an average distance of 228 million kilometers from the Sun. That's 1.5 times farther than us. One Martian year, 687 Earth days. But here's the wild part. A Martian day, called a sol, is only 24 hours and 37 minutes, almost identical to ours. If you moved to Mars, your sleep schedule would barely change. The average temperature? -60 degrees Celsius. That's colder than Antarctica at its worst. But it gets stranger. In summer, near the equator, temperatures can hit +20 degrees Celsius. That's a comfortable spring day. Mars has seasons. It has weather. It has dust storms. Mars has an atmosphere, but it's essentially useless for us. It's 95% carbon dioxide, 2.6% nitrogen, 1.9% argon. The atmospheric pressure is less than 1% of Earth's. That means standing on the surface of Mars is like standing at 35 kilometers above Earth, in the stratosphere. You'd need a full pressurized suit just to keep your blood from vaporizing. But here's what fascinates scientists. That thin atmosphere is enough to create weather. Real weather. Wind speeds of up to 97 kilometers per hour. Frost. Clouds. And the most spectacular natural disaster in the entire solar system. Global dust storms. Storms so massive they can swallow the entire planet for months. In 2018, a dust storm covered Mars completely for over 8 months. It's what killed NASA's Opportunity rover after 15 years of exploration. The solar panels were smothered. The rover went silent forever. Let's talk geography. And Mars has the most extreme geography anywhere in the solar system. Olympus Mons, the largest volcano ever discovered in the solar system. It is 21 kilometers high. That's 2.5 times taller than Mount Everest. But the sheer scale of its base is even more insane. It's 600 kilometers across. If you stood at the center of Olympus Mons, you couldn't even see the edges. The volcano is so wide that it extends beyond the horizon. The rim walls are 8 kilometers high cliffs, taller than Everest's peak above sea level. Is it dead? Maybe. Maybe not. There are recent geological studies suggesting volcanic activity as recently as 25 million years ago. In planetary terms, that's practically yesterday. Then there's Valles Marineris, a canyon system so massive that if it were on Earth, it would stretch from New York City to Los Angeles, and then keep going. At 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep, it dwarfs Earth's Grand Canyon, which would fit inside it like a shoebox. Scientists still debate how it formed. Massive tectonic rifting, collapse, or something we don't fully understand yet. Here's one of Mars's deepest mysteries. The planet has 2 completely different hemispheres. The northern half is low, smooth volcanic plains, geologically young. The southern half is ancient, heavily cratered highlands, billions of years old. The difference in elevation between the two is enormous. Why? One leading theory: a massive asteroid impact, billions of years ago, literally reshaped an entire hemisphere. Mars may have been struck so hard that half its crust was obliterated. Here is the single most important fact about Mars that most people don't know. Mars was once covered in liquid water. Not just a puddle, not just ice. We're talking rivers, lakes, and possibly an ocean covering the entire northern hemisphere of the planet. An ocean that may have been a kilometer deep and lasted for hundreds of millions of years. The evidence is everywhere. NASA's orbiters have photographed ancient riverbeds, delta formations, lake basins, and hydrated minerals that only form in liquid water. The Mars rover Curiosity found rounded pebbles, rocks smoothed by flowing rivers. Perseverance landed in Jezero Crater, which was once a lake fed by a massive river delta. The minerals there confirm standing water existed for millions of years. About 3.5 billion years ago, something catastrophic happened. Mars lost its magnetic field. And without a magnetic field, the solar wind, a constant stream of charged particles from the sun, began to strip away the atmosphere. As the atmosphere thinned, the pressure dropped. Water could no longer exist as liquid on the surface. It either evaporated into space or froze underground. Today, Mars's water exists in two places: locked in the polar ice caps, which contain enough water ice to cover the entire planet in 35 meters of water, and hidden beneath the surface. In 2018, the European Space Agency's Mars Express radar detected what appears to be a liquid water lake buried 1.5 kilometers under the South Pole. Liquid, right now, kept from freezing by dissolved salts and geothermal heat. Liquid water, on Mars, beneath the ice, today. In 1976, NASA landed 2 Viking probes on Mars and did something extraordinary. They ran biology experiments. They scooped up Martian soil, mixed it with nutrients, and monitored it for signs of microbial life. The results were confusing. One experiment, the labeled release experiment, came back positive. It detected what looked exactly like metabolic activity: carbon dioxide being produced, the signature of living organisms consuming nutrients. NASA ultimately concluded it was a chemical reaction, not biology. But the scientist who designed that experiment, Dr. Gilbert Levin, spent the rest of his life arguing it was life. He died in 2021, still believing the Viking landers found evidence of Martian microbes in 1976. We still don't know who was right. Fast forward to today. Curiosity rover has detected methane in the Martian atmosphere. This is a big deal. Methane on Earth is primarily produced by living organisms: bacteria, animals, biological processes. Methane breaks down quickly in sunlight, so the fact that it exists on Mars means it's being actively produced. By what? Geological processes could explain some of it, but some of the spikes Curiosity detected are large, seasonal, and unexplained. Scientists cannot rule out biological sources. The most likely scenario, if life ever existed on Mars, is ancient microbial life that thrived in the warm, wet, early Mars billions of years ago. Perseverance rover is right now collecting rock samples from Jezero Crater, a place that was once a lake, specifically to search for biosignatures, chemical traces that life leaves behind. Those samples are being cached on the surface, waiting to be collected by a future mission and returned to Earth. The answer may already be sitting in those tubes. Mars has 2 moons, Phobos and Deimos. Both are tiny, potato-shaped, and almost certainly captured asteroids. Phobos orbits so close to Mars, just 6,000 kilometers away, that it completes a full orbit in 7 hours and 39 minutes. It rises in the west and sets in the east 3 times a day. And every century, it gets about 1.8 meters closer to Mars. In approximately 50 million years, Phobos will either crash into Mars in a catastrophic impact or be torn apart by tidal forces into a ring, like Saturn's. Here's something that will blow your mind. Sunsets on Mars are blue, not red. On Earth, our sunsets are red because dust scatters blue light away, leaving reds and oranges. On Mars, the dust in the atmosphere is fine and abundant enough that it does the opposite. It scatters red light and lets blue light through at sunset. The result is a haunting, electric blue glow around the sun as it sinks below the horizon, surrounded by a butterscotch sky. NASA's rovers have photographed it. It's one of the most otherworldly images ever taken. Earth has auroras because of our magnetic field. Mars has no global magnetic field. It lost it billions of years ago. Yet Mars still has auroras. They're diffuse, appearing over ancient magnetized regions of the crust. In 2022, NASA's MAVEN spacecraft detected a global aurora that wrapped around the entire planet after a massive solar storm, glowing in ultraviolet. An aurora with no magnetic field. Mars keeps surprising us. Let's get to the part everyone's actually thinking about. Humans going to Mars. This is no longer science fiction. NASA's official goal is a crewed Mars landing in the late 2030s or early 2040s. SpaceX's Elon Musk has publicly stated his goal is to land humans on Mars by 2029, a timeline most experts consider optimistic, but not impossible. The infrastructure is being built right now. Let's not sugarcoat this. Getting to Mars takes 6 to 9 months one way, depending on orbital positioning. The journey exposes astronauts to cosmic radiation, a level that significantly increases cancer risk. NASA's Marie experiment showed that astronauts on a round trip would receive radiation doses, exceeding lifetime safety limits under current guidelines. Shielding solutions are being developed. Water-filled walls, hydrogen-rich materials. But it remains one of the hardest problems. Then there's the gravity. Mars has 38% of Earth's gravity. Long-term exposure causes muscle atrophy, bone density loss, and fluid shifts that damage eyesight. All problems we're already seeing in astronauts aboard the ISS. On Mars, the effects would be more severe and last longer. And the food. You can't ship food from Earth indefinitely. Colonists will need to grow their own. Experiments like NASA's MOXIE, a device aboard Perseverance rover that successfully converted Martian CO2 into breathable oxygen, show it's possible to extract resources from the Martian environment. But scaling up from a small experiment to sustaining hundreds of humans is a completely different engineering challenge. MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment, is perhaps the most underrated achievement in space history. It's a small gold box aboard Perseverance. Between 2021 and 2023, it produced oxygen on Mars 7 grams at a time. 7 grams isn't much, but it proved the concept. A scaled-up MOXIE could produce enough oxygen for both astronauts to breathe and, crucially, for rocket propellant. You need oxygen to burn rocket fuel. Without local oxygen production, every return mission must carry its fuel from Earth. With it, Mars can fuel its own rockets home. Beyond the practical, there's the existential argument. Earth is one planet. One asteroid, one supervolcano, one pandemic, one nuclear war away from the end of human civilization. Mars is insurance. It's a backup drive for the human species. Becoming a multi-planetary species isn't just ambition. In the long view of history, it's survival. Mars is not a friendly world. It will try to freeze you, irradiate you, choke you, and bury you in dust. But 4 billion years ago, Mars may have been a world much like ours. Warm oceans, thick atmosphere, perhaps teeming with microscopic life. Something went wrong. The magnetic field died. The atmosphere bled away. The oceans froze and vanished. What was once a living world became the frozen, irradiated desert we see today. When we look at Mars through our telescopes and orbiters and rovers, we're not just looking at another planet. We're looking at a warning. We're looking at what happens when a world loses its protection. And we're looking at our future home, if we're smart enough, bold enough, and careful enough to make it there. Right now, there are 6 rovers and landers operating on the surface of Mars. There are orbiters above it from the US, Europe, India, China, and the UAE. Every day, new data comes in. Every day, we understand Mars a little better. The first human footprint on Mars will be made in our lifetime. And when that moment comes, when a human being stands on the red dust of another world, looks up at the tiny blue dot in the Martian sky, and breathes recycled air in a pressurized suit, they will be carrying every generation of humanity with them. That's Mars. That's our next home. And the story is just beginning.